Welcome back to Easy Academic. In this episode of the Linear Algebra series, we will be going over 2 by 2 and 3 by 3 determinants. So first we'll start with 2 by 2 determinants, a shortcut for them, and then we'll go over Sarrus Rule for 3 by 3 determinants. So let's say we have a matrix A. We'll define it arbitrarily as A, B, C, D. If we wanted to find the determinant for the matrix A, which is denoted as det A, or determinant of the matrix itself, we could use the simple formula that is A times D minus B times C. So that is to say, we multiply this entry, that is the entry in the top left, by the entry in the bottom right, and subtract from that the entry in the top right times the entry in the bottom left. And this is simply how we'd get the determinant for a 2 by 2 matrix. So let's show an example. Let's say that matrix B is equal to 3, 2, 1, 5. If we wanted to take the determinant of B, which is equal to the determinant of this matrix, we'd find that this is equal to 3 times 5 minus 2 times 1, which is equal to 15 minus 2, or 13. The geometric interpretation of the determinant of a matrix A is given by the area of the parallelogram which is spanned by its columns. So in this example with B, we have two columns. Column 1 of B, which will denote C1, is equal to 3, 1, while column 2 is equal to 2, 5. These two columns constitute two vectors in two dimensions. And so if we were to span a parallelogram using both of these vectors, the area of that parallelogram is what the determinant tells us. And the determinant can be negative. A negative determinant here tells us the orientation of the two vectors. So if we flip the two vectors around, then you'd get the inverse. So for example, if we say vector B prime equals 2, 5, 3, 1, the determinant would be negative of the determinant of B. So let's show this. Determinant of 2, 3, 5, 1 equals 2 times 1 minus 3 times 5. And intuitively, you see that these two entries have been flipped. So since we're subtracting, we would get the negative value. So we'd get 2 minus 15, which is negative 13, which, as you can see, is the inverse. So now that we know the trick for multiplying or finding the determinant of 2 by 2 matrices, we can now show Sarrus rule for 3 by 3 matrices. So let's define a new matrix A, which is a 3 by 3 matrix, A, B, C, D, E, F, G, H, I. And again, this is an arbitrary matrix, just to show the role of each entry. Sarrus rule says that we can rewrite A and add the first two columns to the right of A. So that sounds a little confusing. Let me draw this out so that it becomes a bit more clear. So we have the original matrix A, and then to the right of it, we can sort of partition A original, and then we redraw the first two columns. So this is the representation of Sarrus rule. So what we can do now is we can draw these arrows that will indicate to us what we have to multiply. So first we draw these three arrows through these diagonals. And these three arrows tell us the first three terms when we are that we're going to use when we're finding the determinant. So part of determinant of A is given to us by A times E times I plus B times F times G plus C times D times H, as we can see from uh, these arrows. Now we need to draw 3 more arrows. So we start this arrow from the left of the original matrix A. So we have CEG, AFH, BDI. Now this second part of the determinant is subtracted from the first part. So what we have is this first part, this original part. From it we subtract C times E times G plus A times F times H plus B times D times I. And this is Sarrus Rule. So let's show a numerical example of utilizing this rule. So let's say we have a new matrix B, which is equal to 2, negative 1, 3, 0, 4, 1, negative 2, 5, 2. Now you could memorize this whole expression, but it's easier and more intuitive in a lot of ways to just draw out the 2 columns. So what we have is 2, negative 1, 3, 0, 4, 1, negative 2, 5, 2, and then our 2 new columns, 2, negative 1, 0, 4, negative 2, 5. And then we can once again draw out our arrows. And so what this tells us is that the determinant of B is equal to 2 times 4 times 2 plus negative 1 times 1 times negative 2 plus, we see there's a 0 in there, so we can just disregard this last term entirely. Then from this we subtract 2 times 4 times negative 2 plus 2 times 1 times 5. And again we see that this 0 just negates this final term. And so from this we get 16 plus 2. This is the first part. And from it we subtract negative 16 plus 10. So this term gives us negative 6, which we then multiply by negative 1. So we get 18 plus 6, which is equal to 24. And so the determinant of B is 24. And now for geometric interpretation of B, again, we have 3 columns. But instead of the 3 columns spanning a parallelogram, since this is in 3 dimension, we span a shape called a parallelepiped. And this is essentially the 3-dimensional analog of a parallelogram. And again, you get a certain sign that dictates the orientation of the 3 columns. And again, if you swap any 2 of the columns, you invert the sign of the volume of this parallelepiped. So if you found this video helpful, please be sure to like the video and consider subscribing to the channel. If you have any questions on the concept, please feel free to drop them in the comments below. Thank you.